What's up? I'm Vin, and today I want to go through 2013 AP Calc BC question number 6. So let's get started. So we have P sub n of x is the nth degree Taylor polynomial centered about x equals 0. So it could also be called the Maclaurin polynomial. And we're told here it's known that f of 0 is negative 4, p sub 1 of 1/2 is negative 3, and this is what we have to show. And for this one here, one thing that jumps out right away is that this is first degree. So we have a first degree polynomial. So what I would do for this is write p sub 1 of x is equal to, and we have to know how to write a Taylor or Maclaurin polynomial at any center, but when we're centered at 0, this is going to be f of 0 plus f prime of 0 times x to the first over 1 factorial, which we could leave like this. And we stop here because we're looking for the first degree Taylor polynomial, so we're stopping at x to the first. But now we use the rest of the information. We have p sub 1 of x equals f of 0 is negative 4, so we get to this step here, f prime of 0 times x. And now we're going to use the information that p sub 1 of a half is equal to negative 3. So we have negative 4 plus f prime of 0 times 1/2, and we could set this equal to negative 3. And now we can just do a little bit of algebra. So this is negative 4 plus, we have f prime of 0 divided by 2 when we do times a half equals negative 3. And now just add 4 to both sides, and you get f prime of 0 divided by 2 is equal to, when you add 4, you got negative 3 plus 4 is 1. And now just multiply both sides by 2, and you got f prime of 0 equals 2. So this definitely checks out. So for part B, we're told the second derivative at 0 for f and the third derivative at 0 for f. And we want to find p sub 3 of x. And if we remember what we were told in the beginning, that would be the third degree Taylor polynomial for f centered at x equals 0. So p sub 3 of x, if we expand this a little bit, is going to be f of 0 plus, and we have f prime of 0x, and then next we'd have f double prime 0 x to the second over 2 factorial, and then we're going up to third degree, so we stop at x to the third. A common mistake with these type of questions is that people stop after they write 3 terms. They think third degree means 3 terms, but it means the highest power of x is going to be x to the third. So now we have to use what we had in part A. In part A, we were told that f of 0 equals negative 4, and we're told, well, we found and showed that f prime of 0 was equal to 2. So we're going to use this information from before to get started. We have p sub 3 of x equals f of 0 was negative 4, and then we have plus f prime of 0 is 2, so we have 2x, and then f double prime of 0 is negative 2/3, so we would have minus 2/3 x squared over 2 factorial is 2 times 1, which equals 2, and then we have plus the third derivative at 0 is 1/3, so we have 1/3 x to the third over 3 times 2 times 1 is equal to 6. Now just know on the AP test and the free response, you don't actually have to simplify. So technically I could just leave my answer like this, but if you want to see the simplified, this is going to be negative 4 plus 2x, and then 2 over 2 would cancel, so I'd have minus 1/3 x to the second, and then 1/3 divided by 6 is 1/18. So I have plus 1 over 18 x to the third. So here's our third degree Taylor polynomial. For part C, we have h prime of x equals f of 2x, h of 0 equals 7, and we need to find the third degree Taylor polynomial for h about x equals 0. So the setup is everything for these questions. We have t sub 3 of x because we already used p sub 3 to define the function in part B. So we're going to call this one t sub 3 of x, and this is going to be equal to h of 0 plus h prime of 0 times x, and then we have plus h double prime of 0 x to the second over 2 factorial, and then the last term is going to be h triple prime of 0 x to the third over 3 factorial, and we're stopping here because we're writing a degree 3 Taylor polynomial. So now what we have to do is we're going to use some information from before. We were told that f of 0 is equal to negative 4. We showed that f prime of 0 was equal to 2, and then in part B we were told that f double prime of 0, this was equal to negative 2/3. Okay, so this is actually going to be information we're going to need to complete this, because when we start writing the series here, or I'm sorry, when we start writing the third degree Taylor polynomial, h of 0 is equal to 7. H prime of 0 is the first thing we're going to actually have to go investigate and find. So h prime of 0, we're going to use this over here. We're going to use that h prime of x equals f of 2x. So this tells us h prime of 0 is equal to f of 0, and f of 0 is equal to negative 4. So right away here, we have the coefficient now of x, h prime equals -4, so we have minus 4x. And now we have to find h double prime of 0. But to find h double prime, what we're going to have to make use of here is that h double prime of x is the derivative of h prime of x. And we have to do the chain rule to take the derivative of f of 2x. So we do the derivative of the outside is f prime, and we have f prime of 2x times the derivative of the inside is 2. Which tells us then that h double prime of 0 is equal to 2 times f prime of 0. And f prime of 0 we have over here is equal to 2. And 2 times 2 is equal to 4. So now we have the next coefficient. H double prime of 0 we could replace with 4. So we have plus 4x squared over 2 factorial is equal to 2 times 1, which equals 2. So now we just have one more coefficient to find. So to find h triple prime of x, we just have to do the chain rule again. So we have the derivative of f prime is f double prime. We keep the inside as 2x, and then we multiply the coefficient in front by the derivative 2. So we have 2 times 2 giving us 4. And now this tells us that h triple prime of 0 is equal to 4 times f double prime of 0 when we plug in x equals 0. F double prime of 0 is equal to -2/3. So if we do -2/3 times 4, that's going to give us -8/3. And now we just write in this last coefficient here. So we're going to have minus 8 over 3 x to the third over 3 factorial is 3 times 2 times 1, which is equal to 6. So this, we could technically leave our answer like this, but if we want to simplify things a bit, our third degree Taylor polynomial for h is going to be 7 minus 4x plus 2. And now if we just do this little simplification on the side, if we do 8 over 3 divided by 6, that's going to give us 8 over 3 times 6 is 18. And then divide the top and bottom by 2, and that's going to give you 4/9. So we're going to have minus, and let's just make sure we write the rest. So this was minus 4x plus 2x to the second, and then we would have minus 4/9 x to the third. But once again, you could stop at this line. You don't actually have to simplify in the free response section. As much as that may bother you, I know it bothers me a bit, you could leave your answer like this. Okay, well, this is going to conclude this video on the BC 2013 question 6. Thanks for sticking it out to the end, and good luck on your AP test.